In this episode of FUM0130 machining, we are going to make the two flanges that connect, that are used to attach the heat exchanger between the hot and cold cylinders. Well, here it is like one whole thing, and it rotates quite freely. You can feel the compression there. There is a compression inside this crankcase. Well, because I have been wearing it in, I need to mark these cylinders and this crankcase somehow that when I put it together again, I put it the same way. So these cylinder heads can be swapped together however I wish. But the cylinders need to be about in the same orientation, rotating wise, and also they are paired with the piston, and the piston needs also to be in the same orientation. For this marking I'm going to use my Dremel. It is at the moment I have 1 millimeter carbide drill there. These drills are actually used in electronic industry for printed circuit boards. They are quite cheap actually. You can buy them quite cheaply. If you need to drill holes that are really small, these are really good. But there is a catch here. These are really brittle. So if you use these, be prepared to break them often. Especially when you are drilling like I'm going to do this one by hand. And yes, well, let's put here some dots. And this is really a delicate operation with this drill. Sorry if you don't see this, but I try to keep my hands steady. I will put one dot here. Yeah, it tries to wander around. Oh, I want to put... Oh, this is really horrible. Horrific. Okay, I have one dot now there. Then one dot for the cylinder as well on the same place. This was easier. Okay, nice dots. I don't want to use the marking punch for this one. And now this side and okay, it's marked and really still whole. Yeah, sometimes those, when you drop them on the wall, they break. Okay. Next thing I will start to dismantle it, and I will start from this side. Well, I will speed up this process. It's really, it would be painful for you to watch me to separate these things from each other. So, that was the dismantling of the machine. One thing that needs to be done before I even try it out is to get some heat insulation in this side of the engine. And this is done by a material I have handy here. It is PTFE. Let me show you. This is the material. Some guys who are working with electronics probably notice that this is, it's just ordinary printed circuit material. Well, it's just not ordinary printed circuit material. This has copper, very thin copper layer on both sides, and then in between is sandwiched PTFE. So this is very special, and it cuts with scissors quite well. It has some fiberglass, so it will destroy your scissors, maybe. And now the what is difficult here is to make the correct holes into this material. Well, here we go. First of all, I will be using, well, drill press for this one, for the four holes around. There will be 4 holes and a 16mm hole there in the center. So the four holes I will do in drill press, and the center hole I need to, well, I need to mill that manually, really manually. So let's see what we have here. So first of all, I want to cut a suitable piece from this. I don't want to hold the whole plate on my hand. So, well, what I'm using here are these scissors. They look like toy, but they are nothing but a toy. Hopefully you can see the brand here. It's Fiskars. And there are a lot of Chinese copies from these. These are really, really good scissors. These are more than 15 years old, maybe 20. And they are still sharp, really, really sharp. And well, let's see. So this material is somewhat tough. Let's take that much. And it cuts like butter. With this, really, it does. I think that one is good for me. Yeah. Okay. Now we have, and this is really quite flexible, and put this aside. And now, what I have planned to do here is to use this sacrificial piece of aluminium, put this here and that on top of that, and clamp everything with my tiny little thing. Well, let's see if I can do this. There, it should tighten quite well. Yeah, it's rigid. And now I just go to my drill press and drill these to 5mm. And I'm going to use high-speed steel drill. This contains glass fiber also. It might mean that I will destroy the drill bit, yeah, because it's glass. It will not be very sharp after this operation. Well, here we are back in the workbench, and now the first thing I want to do with this is to mark the outline of this, because it's not sitting straight. This is for later, for me, when I cut the piece to the actual size, so I know where to cut. Now I can take it apart from here. Let's see what comes out. Well, good holes, I believe. Very good, actually. And this one was really sacrificial. So, let's see how I could find out the center of these. This is, well, okay. So let's take that one first. Draw a line there. And then do the same here. In this direction. And the last one now. And again, so that I barely can see the holes. Just barely. There you are. And now we have a rectangle in there in the middle. Oh yeah, that's good. And then I just draw a line with this rectangle. There is one. Well, it looks like a good one. And then I take one of these things. This is coffin nail, and make a dent there. Oh yeah. This was because I need to use this to get to have the 16mm hole, and this is not metric. Okay, was not metric, so I need a 16mm, so it will be 8. Half of that will be 8. So about there, not about, but exactly. I will make it 1mm larger. There is a reason for that. Okay, and now just make it. Oh yeah, it's better to rotate this piece than rotate the. Now I have it there. Now that I have marked this surface, well, next step will be to use a drill. And now the drill is in my Dremel. This one we don't need anymore. And well, let's see how this goes. I need to make a hole somewhere in the vicinity of the edge. Oh, this goes really easily. Let's make a little bit more holes there, because they were so easy to make. Oh yeah, we have some holes now there. And now the next thing will be, well, this drill is really sharp. That's a good thing. So now the next, this is actually mill. And now we need a lot more speed. 15,000, and it's not 1,500, it's 15,000 revolutions per minute. And let's see how this goes. I need to go to the oh yeah. And then I will enlarge it until I don't see the line anywhere. And we are done. Well, now we have a very good hole there. My really nice scissors, which are and precision cut. Yeah, it is really precision cut. These are really nice scissors. And now the last one. Oh yeah, and there's your thermal insulating seal. So now it's deburred and it's ready for use. Oh yeah, now I have actually what I did. I decreased all the parts. These cylinders will work without lubrication. And this is, well, I have figured it out that the combination of metals is really good for that thing. Let's see what happens, but this is really, it's actually sliding very easily. With oil it doesn't slide that easily, and it's tight. It's really tight. So now let's put this together. Well, here is the plan this time. We need to have something to attach a tube in between here, this point and that point, and it will be something like this. Well, actually this is the material I'm going to make the tube. When the time comes, it becomes a heat exchanger. There will be something inside. Yeah, of course a hole, but something else as well. But as you can see, they are still a little bit of an angle here. So we need to do something like this in order to be able to connect those this tube. And for that I need to do, first I need to do two pieces of material, make them beautiful in the milling machine, size 30 times 16 times 18 millimeters. After I have finished these parts, I need to do some milling on them. And this happens in a vise which is tilted, so that I can make this cut. There will be material cut away from this corner, and then I will drill a hole and make a thread inside there. Here we are. This is the piece we should make, well, a little bit more like it should be. The first thing, of course, because I have had hacksaws, this is to debore it before even trying to put it into there. So I will just take the corners, because there will be burr. Oh yeah, now it's better. There are two semi-machined surfaces here, this and that. So I will put it this way in the vise. But we need to have something here. First of all, near the corner, I would like to have something like that, so it doesn't touch the bottom. So the bottom doesn't. And now we need to know whether we can. Let's see. I have to measure something here, and then put another here in between. And there you are. It's about there. Then just tighten it there. This is going to take forever. So I will increase the speed and come back when I'm done. So it almost get rid of the hole. There is a very small dimple, but at the moment I'm so near the vise that I don't want to continue milling that one. Well, maybe I'm a little bit paranoid, but I really don't trust this vise. Well, now I'm just trying to get this perpendicular, this surface, and clean it up now. So let's see how it goes. So I have a parallel here behind, which is clamped to the vise, and then the piece is clamped to the parallel. And then this is only held by the vise. I have this copper wire here, because these jaws, this jaw is lifting quite a lot actually, and now because I'm clamping it on the side, it will also bend So yeah. Yep. So now we should have a very good piece of material. Well, horrific burr. This mill produces that kind of burr on the exit edge, and it's really I have noticed that the easiest way to get rid of it is this tool. First you just do like this, and then you file it. Okay. This is actually should be 30 millimeters now. Well, not too shabby. It's 1/100 of a millimeter oversize. Let me show you if I can switch off the autofocus. I mean on the autofocus, and if it now focuses here. Yes, it did. So this here is the setup for milling this little bit strange thing. Let's go a little bit nearer, and I will milling this one until I get 10 millimeter wide flat here. And since this setup is really flimsy, it's only 3 millimeters on each side, I'm using a very sharp. This insert has a very sharp edge, and I'm going to mill, I don't know, very little as is practical. And after that, after I have this 10 millimeter flat here, I will then yeah, let's see what happens then. But now I will put you into a suitable place so that you can see this, and I will speed up this process a little bit, so yeah. Well, that's a really nice finish. I noticed I had to take only 0.3 millimeter cuts. Then these very sharp edge blades took very good cuts. And not pushing a burr, etc. And now the next step will be to mill here two sides, so that we are leaving only 10 millimeters times 10 millimeters square thing here in the middle. this is the final product. Yeah, the other one has this M8 thread, and it has all the features here that are needed to attach this this one, because it has the thread, is attached to the hot side, like that. And the other one goes to the cool side. Okay, well, that's it. And now we should be able to put the tube there in between when that time comes. Okay, so here are the two things that we managed to make. Well, there are some miscalculations there, like that. But other than that, tiny thing, they sort of look like very good. Well, usable components. Well, in the next episode of FUM0130 machining, we are going to make the tube between those cylinders, which is actually the heat exchanger. Till then, bye!